Hey, good morning, Algebra 2, and welcome back to another week. Including today, including this week, I believe we have 6 weeks left of the school year, okay? So let's dig in, finish strong. So this week, we are going to start talking about probability. So last week, permutations and combinations, those are related to probability. However, probability, as you can see here, hopefully, is... Get my highlighter. So it says the extent to which an event is likely to occur. It's measured by the ratio. So hopefully you know a ratio, something like a fraction, okay? And it says the ratio of the favorable cases, okay? So on top, we're going to have the favorable. Now you might not be certain what that means, and we'll talk about that in a minute. And then on the bottom, it says it's the ratio of the favorable cases to the whole number of cases possible. So another word for the whole number would be like how many total cases there are. And that's what's going to go on the bottom. So favorable on top, total on the bottom. Now, favorable, if something is favorable, you like approve of it, okay? It satisfies our conditions. So if we look here at this first problem, it says we are trying to take a look at this bag. It contains 3 yellow marbles, 2 orange marbles, 7 red marbles, and 4 green marbles. And we want to know, what is the probability of picking an orange marble? Okay, so we'll solve this one with an orange color. And first thing we want to do is establish on top, it says the favorable. So an orange marble. How many orange marbles are there? And hopefully you can see right here, there are 2 orange marbles. So 2 will go on top. Now on the bottom, we put the total. So we have to add up all the marbles. There's 3 yellow, 2 orange. So 3 plus 2 is 5, plus 7 red. So 5 plus 7 gives us 12. And then plus 4 green give us 16 total marbles, okay? So there's 16 total marbles. And that will be important to us because that's the total amount. If I reach into the bag, okay, I'm choosing one of those 16, okay? I don't know which one, but I know I'm choosing one of those 16. It could be yellow, orange, red, or green. Now, 2 of them are orange, so that's why we have a 2 on top. There's going to be 16 on the bottom. Now, we can leave our answers as a fraction for this probability chapter. However, 2 over 16 is not good enough. We need to reduce that. So think to yourself, what goes into both 2 and 16? And hopefully you get the answer of 2. 2 goes into 2 1 time, and 2 goes into 16 8 times. So 1 over 8 is our probability of picking an orange marble. Now, we'd be done with that. However, please leave it as a fraction, okay? You could write that as a decimal, but I think it's easier if we just leave everything as a fraction. Now, this second one, right here, it says P parenthesis yellow. That means what is the probability of picking a yellow marble? So once again, on top, we're going to have the total number that are favorable. So how many are yellow? So right here, we have 3 yellow marbles. So we put a 3. And on the bottom, we put the total amount. And we added that up for the last one. There's still 16 total, okay? Now, in this case, we are assuming that we have not taken any yet. It's not like we pull down an orange one and then we're trying it. Okay, there's still 16 in there because we haven't taken any out. So 3 over 16. So we have to think for a second. Can that be reduced? 3 does not go into 16. The only thing that goes into 3 is 1 and 3, so no, it cannot. Okay, now our final one on this problem. Okay, it says a red or green marble. So it's an or question. We know this one is still out of 16 total marbles. It can be red or green. So it could either be these 7 red or it could be one of these 4 green. We need to add those together. If it's or, that means either one. Okay, so it could be red or green. 7 plus 4 is 11. So right here we have 11 over 16. Think to yourself, can that be reduced? Only thing that goes into 11 is 1 and 11, so no, it cannot. Okay, so now let's take a look at another example here. It says 28 people in your math class, 10 sophomores, 13 juniors, and 5 seniors. So if you want to double check quick, 10 plus 13 is 23, plus 5, 28. Okay, 28 total. They're either sophomore, junior, or senior. says, what is the probability that someone is a sophomore? So we know that on top, we're going to have the favorable. So how many of those are sophomores? We look here, 10 are sophomores, so we put 10 on top. Okay, on the bottom, it says, or on the bottom, we want to put the total. We know there are 28 total, so we do 10 over 28. Now, in order to solve this, we need to reduce. So 2 goes into 10 5 times, and 2 goes into 28 14 times. And we quick check, can 5 go into 14? No. So we are done. Now our next one, the second part on question 5, it says, find the probability that someone is not a senior. Remember that P means probability, okay? And the parentheses mean what's the probability of that happening. Now this time it says not a senior. So if someone's not a senior, they could be a sophomore or a junior, okay? So 2 ways you can come up with this. We know the total amount is still 28 on the bottom. And for not a senior, you can either take the total 28 minus the seniors. So you could do 28 minus the 5 seniors and you'd get 23. Okay, and put that on top. The other way you could do it, if you're not a senior, you're a sophomore or junior. Sophomores are 10, juniors are 13. 10 plus 13 gives us 23. So either way, we get 23 over 28. Okay, we have to double check, can that be reduced? 23 is a prime number, meaning the only thing that goes into it is 1 and 23. And neither of those, well, 1 would go into 28, but that doesn't help us. Okay, so now, your final section here, we got 3 problems, and it says, what's the probability that you spin? So we look here, and here's our graph, or our spinner. So imagine there's an arrow here. Ooh, that one's crooked, but it would still work. Okay, similar to what you do like on the game of life. Trying to think other games with spinners, but hopefully you get the idea. This, I can't think of any other games with spinners right now, but the game of life, you spin it, you see how far you move. Okay, so what's the probability you spin? So this first one says a 5. So if we look, there are 6 different spots. 1, 2, 3, 4, 5, or 6. And we're assuming that each of these is equally likely. Okay, it doesn't say that, it probably should, but so we know the total amount, there's 6 different ones. Okay, what's the probability you spin a 5? There's only one space that has a 5. So, oops, let me fix that. So it's going to be 1 over 6. Okay, now the second one. What is the probability that you spin an even number? Okay, so once again, we know there's 6 total, and how many are even? So if we look over here, that'd be 2, 4, and 6. Okay, 2, 4, 6, 8, 10, 12. All right, anything that's multiple of 2 is an even number. So there are 3 of them that are even. Now, we're not quite done. 3 over 6 can reduce. 3 goes into 3 one time. 3 goes into 6 2 times. Okay, now this final one, find the probability that a number is less than 3. Okay, less than. So if we look here, 6 is not less than 3. 5 is not. 4 is not. 3 is close, but it's equal to 3. This clearly says less than 3. Okay, so 3 does not get included. It would either have to be 1 or 2. So you got 2 possibilities. There's still 6 total spots for your spin to stop on. So 2 over 6, if we reduce that, 2 goes into 2 once, 2 goes into 6 3 times, and we get 1/3. Okay, so that is all we got for today on probability. Go ahead. I believe there's 3 different questions for you guys to try. If you're not caught up on assignments, please keep up on Chapter 10. Okay, we're finishing up this week talking about probability. We'll review some next week, and I believe at the end of next week we'll come up on our test. So make sure you get caught up on probability. If you have any questions, please reach out to me and let me know. Have a great day, and I'll talk to you guys later.